Okay, so we're back. We were talking about a problem. We were given that sine of x is 1/3. It's in the first quadrant, and they want us to figure out what sine of pi over 4 plus x is. And right now, so we've plugged in this formula to see what this will tell us. But before we do go any further, let's make a picture and see what we can discern from it. And I'm going to try and leave this up here for as long as I can, but eventually I'll have to erase it. So at some point, stop this and get those copied down. So here's our graph, our Cartesian plane. Here's the x-axis and the y-axis. So we have sine of x is equal to 1/3. What does the picture then look like? Well, sine of x is this divided by this, so this must be 1 and this must be 3. From Pythagoras' theorem, we know that this is 3 squared minus 1 squared square root, which looks like square root of 8 on a good day, and in general, we would probably write that as 2 times the square root of 2. Okay, so now we've added pi over 4 to this. So incidentally, here is something that will drive you a little bit crazy because I'm using x in two different contexts here in a certain way. This is the x-axis. This angle is x. Truly, maybe we should put a little caret on it. Using things in two different contexts really drives people crazy who aren't used to the idea. But so this is some angle x right here. Pi over 4 plus x, well, so I'm going to add 45 degrees to it, which, and this is just some approximation, right? And now I have this, and this is the angle here, pi over 4 plus x. Well, so we have some information here. Let's figure out. So remember now, this is an angle. It's a chosen angle. And so let's figure out what this stuff is. Sine of x is 1/3. Cosine x is going to be this divided by this. Let's put this up as well. So this means that cosine x is 2 over the square root of 2 divided by 3. That's an ugly looking 2. So now let's try and figure out what this value is here. And we resorted to our equation. Sine of pi over 4 is 1 over the square root of 2. That's one of those things I was hoping that you'd memorize. So this says this is 1 over the square root of 2 times cosine x. Cosine x, we've already figured out, is 2 square root of 2 divided by 3. Plus sine of x, which we've already given as 1/3, times cosine pi over 4, which is 1 over the square root of 2. So this cleans up a little bit. Okay, so let's just do a cancellation here. Look, at this point, you can plug this into your calculator if you want. So this is 2/3 plus 1/3 square root of 2. We'll do this square root of 2, square root of 2. This is 2/3 plus square root of 2 over 6. Oh, you know what? So, okay, this is 4 plus the square root of 2 divided by 6. First off, we should think about this. Does this answer even make sense? Remember that sine and cosine are bounded by 1 and minus 1. Let us take our calculator. I can look at this. I see this as less than 1. It's okay, but until you're used to it, you want to make sure. 2 square root divided by 6. And this is 0.908, or sorry, 0.9023 and some change. 0.023 and some change. Can you hold it 1 second? Okay, so yeah, I took a little pause and went back in your book and looked at the answer. Because here's what's going to happen, especially with these trigonometric identities and when you get into calculus. The answer in the back of the book can oftentimes be written in terms that don't necessarily look like your answer. I've had a lot of calculus students look in the back of their book, especially in Cal 2, when we're doing a lot of trigonometric substitutions, and end up with something that looks different than the answer they got, but they're in fact right. It's just recognizing when these things are the same. As far as it goes, okay, so this is what the answer is. Technically, that's listed in the back of the book. I prefer answers that look like this as opposed to decimal points. Physicists, on the other hand, because they're practical bound people, will want numbers that are in decimal form in general. Once again, just try and make sure you understand what your instructor really wants from you. Okay, back to the confusing thing again. How come they're using x for an angle and they didn't say sine of alpha? Well, so remember when we graph these, and this is not an accurate representation, I'm just going to be hasty. Here's sine x, not very good graph. Remember, then this is when x is equal to whatever it was that made sine x equal 1/3. It comes from using the graph on the x-axis, right? I guess if I were doing it, I would have listed this as sine alpha, and I probably will in my problems. But just be aware of it, and you know, part of the confusion with mathematics is trying to keep everything in context, try to understand the specific use of the jargon at hand, and just keep everything in mind at once, and you get used to it. That was a good problem in the sense that it's going to start getting you used to the kinds of exam questions that you'll be having very shortly. So we're going to do some more. Oh, how about this one? They want us to simplify the given expression. This one looks nasty, well, semi-nasty. Sine x minus y times cosine x, I think it said. Where did you go? Oh, cosine y. What do we have here? Plus cosine x minus y. X minus y. Sine y. Now I'm going to check and make sure that I have written this down correctly. I cannot tell you how many times I end up putting the wrong problem on the board and solving it correctly, but then the students go, hey, wait a second, that's not the answer in the back of the book. Oh, it's because I didn't write the problem correctly. Okay, so what am I going to do right away? I know that sine x minus y is sine x cosine y minus sine y cosine x. Then it'll be times cosine y plus cosine x cosine y. The minus makes this plus sine x sine y. And this is times sine y. What do we got? We distribute through. This is sine x cosine squared y minus sine y cosine x cosine y plus distributing cosine x cosine y sine y plus sine x sine y squared. And what do we got here? Fortunately, I believe these cancel out, which makes the mess a little smaller. Here we can factor out sine x. This is sine x times cosine squared x plus cosine squared y plus sine squared y. This is just sine x. And my producer is telling us it's time to jump again. See you.